All right, the topic we are working on today is called identify rational and irrational numbers. And the quick code for IXL is NV6, eighth grade. And we're working on figuring out rational versus irrational. Okay. Now, the easiest way, I think, to do and identify whether a number is rational or irrational is to quickly find out what an irrational number is. There's only a few kinds of irrational numbers, but there's a ton of rational numbers. So rational numbers are numbers that could be written as a fraction. The numbers that cannot be written as a fraction are numbers like pi, right? The symbol pi in particular, okay? Now if you see something like 3.14159 like this, that means that just like pi, this number is never ending, keeps on going, and it never repeats, okay? Which means it doesn't have something like the line over it, okay? If it has the line over it, if it's repeating, it is rational, okay? So non-terminating, non-repeating numbers are irrational numbers. If they repeat, they are rational numbers, okay? Also, if you have something that is not a perfect square, it's irrational. I can call this the irrational quality or category, irrational. Okay. So for instance, we know that square root of 8, there's no two numbers that multiply together perfectly, whole numbers, to give you 8, right? Because 2 times 2 is 4, 3 times 3 is 9. So the square root of 8 is an irrational number. It's not a perfect square. On the flip side, a rational square root would be something like 4, right? Because 2 times 2 gives you 4. That's a rational number. It's a perfect square. Or square root of 81, because 9 times 9 gives you 81, okay? So just that real quick mini lesson, pi, non-terminating, non-repeating numbers, imperfect squares or non-perfect squares. Those are all irrational. So I'm going to go through these and you're going to hear me repeat a lot of things, okay? So this is a fraction, so yes, that is a rational number. Okay? Is this irrational? No, because it is a fraction. If it can be a fraction, unless it has pi in it, it is a rational number. Irrational? Nope, because it's a fraction. Okay? Is this irrational? No way. It's a whole number. Whole numbers are rational. Oh, wait a minute. I didn't read that correctly. Is it irrational? Oh, whoops. It is not irrational. Got it. Is this rational? Yes, it's a number. It can be written as a fraction. Is this irrational? No. Let me show you real quickly why. Ready? Watch. 5.578 is the same thing as 5 and 578 1,000ths. So as soon as you can put it into a fraction, it becomes rational. So this is not irrational. Okay, I'm going to jump up a little bit. Let's jump up to this level. So can this be a fraction? Yes. So is it irrational? No. Can this be a fraction? Technically, yes. It's a whole number. 0 over 1 is still 0, right? 2/7, that's a fraction, so yes, that's rational. Can this be a fraction? No, that's not rational. That's pi. Pi is irrational. Can that be rational? Yes, -6 over 1. Can this be rational? Definitely. It's a fraction. Fractions are rational. All right. Is that irrational? Nope, because it could be -34 over 1, which is a fraction. Okay. Is this rational? Yes, -70 over 1 is a fraction. Okay, so we have a repeating decimal. And remember, I said repeating is rational, so it is not irrational. Okay, which of the following is rational? Well, that's irrational because that's pi. This is rational. These are non-perfect squares, which makes them irrational. Okay. Which of the following is irrational? This is irrational because it's pi. Okay. Which of the following is rational? Whole numbers are definitely rational. All of these are imperfect squares, and that is pi, making them irrational. Okay, which of the following is rational? Not pi. These are non-perfect squares. This is repeating. Repeating is always rational. Remember, the line makes it rational. Which of the following is rational? Not pi. Not non-perfect squares, whole number, because this could be 69 over 1. Okay, let's get to 100 on this one. I know we can do it. Irrational, let's see. Non-perfect square. The rest of these can be fractions. Irrational, pi all the way. Rational, we've got these are whole numbers, that's a fraction, and that's repeating. All of those are rational. All right, irrational, definitely pi. Definitely square root of 22 because that's a non-perfect square. And those are the only two that are irrational. Okay, pi is not rational. This can be rational, rational, and rational. Any whole number is always rational. Rational, fraction, can be a fraction, can be a fraction, can be a fraction, all of them, right? Just a couple more here. Can that be a fraction? Yes. Can this be a fraction? Yes. Can that be? Nope. Can this be? Yep. And irrationals, that is a non-perfect square. That is pi. Both of them are irrational. And one more, irrational would be square root of 315 is a non-perfect square. Remember, that repeats, making it rational. These both can be written as fractions, and we are set.